Welcome to Unlocking Potential, a podcast from Baldwin Technology. We're fueled by 100 years of innovation, providing the top hardware, software, and consumables to automate, enhance, and apply intelligence to production processes. Join us and learn how you can unlock your full potential. Welcome to Baldwin's Unlocking Potential podcast series. Today, we'll explore innovations in LED UV curing for industrial applications. I'm your host, Tyler Kern. With thousands of UV and LED systems and more than 10,000 IR systems installed around the world, AMS Spectral UV, a Baldwin Technology Company, manufactures high-power and versatile LED UV, and IR systems. They're used by a vast range of industries to cure or dry inks, coatings, finishes, treatments, adhesives, and polymers. AMS Spectral UV was first to develop high-power, large-format LED UV curing systems, which, along with conventional UV systems, is customized to suit wide-ranging applications that require high performance, resiliency, and reliability. This encompasses everything from highly specific laboratory-grade systems to large-scale, high-speed manufacturing lines. The company also manufactures robust IR drying systems that can be utilized in converting and other industrial processes. AMS Spectral UV offers an extensive range of standard technologies, all customizable to specific applications with a number of standout features. AMS Spectral UV can provide partial or complete systems tailored to the technical specifications, including electrical and cooling requirements of every setup. And now to delve deeper into the many innovations in LED UV and its wide-ranging industrial applications, please join me in welcoming our guests, Hans Ulland, Executive Vice President for AMS Spectral UV, and Michael Derrick, AMS Spectral UV, Director of Projects and Key Accounts. Hans and Michael, guys, thank you so much for joining me here on the podcast today.
You bet.
Thanks for having us.
Absolutely. So, Hans, let's start off with you. You have played a significant role with AMS Spectral UV and its pioneering LED UV technologies. Just give us the backstory that laid the foundation for the company's leadership in industrial UV applications today.
You know, I had the privilege of becoming one of the founders of Air Motion Systems over 20 years ago, and we kind of jumped right into the high-powered UV area of the graphic arts market, and we rolled forward from that standpoint. Then in about 2006, my business partner, Steve Metcalf, was at a Drupa, recognized the potential value of LED as a way of producing UV spectrum. And he went ahead and started us down that path. So I give him a lot of credit for doing that. We were very early into the way LED was functioning, and we went out and bought some of the very earliest prototypes of chips or dies, however you want to call them. And we used to actually have to cut the chips apart by hand with a saw, which was a little bit delicate, especially at the cost that those things were at. So we started very early on and trying to jump into this market to see if we could find LEDs that were going to be powerful enough to be able to handle inks and coatings in the graphic arts market. Once we achieved that, it just really was a springboard moving forward. We got into all high-powered applications that were available with LED.
That's fantastic. You know, and ultraviolet light has been used in industrial processes for a long time, right? And
Right.
The technology for using LED to produce UV is relatively new and only being commercialized in the mid-2000s. So what has your experience been as a pioneer in industrial uses of UV LED technology?
Well, it's certainly been interesting, right? So the demands that the industrial businesses would bring to us would be, can you please produce something that's, 76 inches wide and have this many millijoules and be able to produce many, many different wavelengths. And so the demands were great right away. And unfortunately, the commercially available product, the epitaxial material, was simply not available at the time. So we continued to work with all the different suppliers, and we really focused our abilities on becoming a world-class integrator of LED chips to the industrial businesses that were out in the marketplace. So we would get people that would come to us with a requirement, and we would work with them diligently to see what was possible. We'd search the world over to get the materials, the core materials that we needed to manufacture it, and then we'd build the best possible system for their application, working carefully with them every single day.
And I guess as a follow-up question, how have things changed since AMS created its first UV LED curing system back in 2009? Hard to believe that's 12 years ago now.
Yeah, it went pretty fast, actually. Well, first of all, we don't have to cut the bases of the chips with the handsaw anymore. That's certainly helpful. And the other thing is that the commercially available materials for us to use are really vast. We made the decision not to go ahead and manufacture the actual dies themselves. We do all the work with the design of the dies and the requirements of the dies, but there are multiple options in the world that can produce what we need them to. So we can actually specialize in meeting the customer's needs and not have to spend all of our time building the epitaxial material to make LEDs work. So for us, it's all about integrating the best that's available in the marketplace for the customer. And again, what's commercially available is just incredible. We started with 400, like everybody, right? You had 400 nanometers with kind of the ideal, and then you went down to 385. And that UVA base, that's a decent place to start, but it's not going to change the world necessarily. As we got going, we were able to find that we can make commercially available lower wavelengths that met the customer's requirements a lot more easily. Did that answer it?
Yeah, I think so. I think that was fantastic. And so, Michael, we haven't forgotten about you. You've been quiet for far too long. So, Michael, tell us a little bit about your background and how you ended up here.
Yeah, so I'm an engineer background. I guess I got my mechanical engineering degree at Iowa State University, and then I came and started working at AMS over 12 years ago. Started in engineering, kind of a design engineer. Along the way, I've gotten my MBA as well, but basically I've spent the last 12 years working around developing and integrating kind of the LED and conventional UV systems into industrial processes and other applications.
So, Michael, as a resident expert, what are the advantages that LED-based industrial UV systems have over traditional mercury-based UV systems?
Yeah, so a lot of their advantages have really allowed them to start taking off in the past few years. There's still places where you see conventional UV used, but for the most part, the LEDs have they have a much more focused energy spectrum. So a conventional UV lamp is kind of like a blunt force hammer. You're going to get the wavelength you need, but you're also going to get a ton of other wavelengths, infrared, which is basically just heat. And all that other wavelengths basically just waste energy. So with the LED, you're just getting that one specific peak energy beam at the exact wavelength you need. So most cases it's 365 nanometers, 385, 405, 395, and that peak energy band allows you then to basically customize the chemistry of whatever you're curing and to be very reactive at that peak band. So when you dial that in, basically you can oftentimes replace 10 or so, for example, like 10 conventional UV lamps with just one LED UV lamp, which obviously saves you costs and a great amount of energy. Some of the other benefits is there's no ozone emitted with LED UV. All of our systems are water cooled. Mainly for high, because we build higher power applications, but there's no air extraction or fans or things like that you are required to have with conventional UV. LED lamps are also all solid state. There's zero moving parts. So, from a maintenance standpoint, wear parts, things like that, the LEDs just don't wear out, and need maintenance as often as conventional UV lamp heads. They don't have lamps that need to be replaced every 1,000 hours like a conventional UV lamp. So that saves you kind of downtime and process time. They're also instant on off, which is really nice with LEDs, is that you can turn them on off incredibly rapidly. And conventional UVs, typically they have a warm up period, and then they run, and then after you shut off, so let's say you have a line stoppage or whatever, you have to wait for the lamps to cool down before you can start them up again. So you end up, wasting a lot of valuable process and running time with the conventional UV lamps, where the LEDs just turn it on and off a light switch.
Well, I think you gave a pretty strong argument there for many of the advantages for LED UV over more traditional methods and that sort of thing. And Hans, one question people might have is scalability, right? So how scalable is an LED solution, and is it possible to take lab or prototype production requirements and scale up to industrial production scales with LED UV?
So really, LED is an absolutely fantastic technology to use to really get into all those nooks and crannies that you need to be able to get to when you're curing. UV's big limitation is that you have to have a tremendous amount of and technology involved and cost involved in reducing and removing the heat associated with it. And you can only put the UV output in areas where it made sense in long, straight lines. So from a scalability standpoint, and we are a little bit unique in this way, we can build you as wide of a module as you need at incredible levels of both output and dose, or as limited as you need. Right. So an average system for us is at least, 60 inches wide. That's typical, but we also go up to 3 meters wide without any kind of problems. But then we can also handle things where if you need to get into some really unusual 3D curing, right, where you're curing a part or a piece that's very unusual, we can provide that technology as well. So LED is way more scalable and usable from an industrial standpoint than any other UV source that's out in the marketplace.
Yeah, kind of just to tack on with what Hans has said. The optics we have basically with some of our lamp heads kind of allow us with those 3D parts to be able to cure it or maintain the intensity needed for curing at longer distances away, but still have basically a collimated beam of light so that, close or far, you're getting still amount of good of intensity. So you're not just throwing all the light out, 100 millimeters away from the lamp. You have kind of the same beam the whole way down, which is really nice. Also, to add on, some of the, one of the things that we specialize in really is the, high power wide systems like Hans was mentioning. That's kind of what we pride ourselves in the market as we can go, bigger, more powerful than the other guys and custom. We'll do whatever solution meets your needs from one lamp up to 12, 16 lamps. Whatever you need for your process, we're willing to work with you and provide the best solution for you and meet your needs.
Exactly. I just want to jump in a little bit. So we have customers that'll come to us, and we'd love to talk about them, but we have NDAs with virtually every single one of them. But we can take a look at something like the screen industry. We needed absolute uniformity to be able to successfully help a customer develop out the way that UV is used in the OLED screen manufacturing process. And that uniformity was absolutely key. And we worked with them directly with the rest of our engineers, and we were able to provide essentially what becomes like a top hat kind of scenario. So we're able to give them exactly the energy that they needed. In this case, it was not a huge hit of energy, but just super consistency. So uniformity is also a big part of it. LED is fantastic at that. UV is very difficult to achieve perfect consistency across a wide area.
Yeah, I think one of the other things that we can offer too is kind of a fun thing talking about high power. So basically, we have all of our standard platforms. We have several are all kind of around the same amount of dose level. And UV dose is kind of a measurement of intensity over time, which is the best way to put it. So you can increase your dose basically by just leaving a part underneath the lamp for longer. But we have a product that so we have all of our standard products kind of fall in one range, and then we have one product called our XS model, which we lovingly refer to as the dose monster. But it'll actually output 4 times the dose of kind of our other standard products, which is pretty incredible, and we've already found kind of some unique uses for it, just to be able to put that much power down in one kind of packaged head into a process is pretty incredible.
Keep an eye out for the Dose Monster coming to Netflix soon. New animated series from Baldwin. But Michael, I wanted to follow up on that. Can you give us a sense of the diverse industrial applications that you've served with LED UV processing technologies? I'm sure that there's a wide range of applications and industries that you serve with this.
Ink's obviously a big one, graphic arts and things like that. Adhesive, started to get in some things with UV curable powder coating, which is pretty incredible because instead of basically using giant, gas dryers and ovens and infrared, you can basically just use UV to accomplish the same thing. Things like varnish for wood products, various incredibly different types of coatings. As Hans mentioned earlier too, we've used this stuff in the electronics manufacturing industry. Pretty incredible, and that's been going on for years. It was almost one of our first uses for the LED UV technology. But basically, UV is used as a curing process to basically turn anything that gets applied as a liquid that needs to become a solid or a semi-solid. You can typically formulate that with photo initiators to react with the LED UV or conventional UV lamps to basically dry it faster. Really with the technology, there's things that come up every day that that are new to us, different applications for it, customers contacting us saying, hey, we have this, can you do it? Or, curing in vacuum chambers, all sorts of cool stuff.
I want to jump on that a little bit too, Michael, if that's okay, because the way that we work with companies is a little bit different than what some of the other LED curing technologies are out there. So we don't just supply you like a standard, 10-inch wide unit. You call up Amazon and get it delivered to your door and try it out in your lab. We need to work with companies that are starting at the lab process, and then we really get involved with them when it moves into the proof of concept phase, right? That's where we go ahead and we start building out prototype production equipment for them that meets their requirements. So if it's in, you name it, we've done it, right? And we'll continue to do it. And then that proof of concept is what transitions into a fully, generally speaking, automated industrial application. So we actually go through and work with these customers from the very beginning of what they're talking about doing, but more importantly, from when they actually have to produce it to then making it a production piece. And as an example of that, there's like no little weak components in any of our systems. So we've had this said to us many times that our equipment feels like a real heavy duty piece of equipment, no little plastic pieces to fall off, break off, and cause a problem in an industrial application. Because almost everything we build then turns into a 24-hour, 7-day-a-week production piece of equipment.
So Hans, the trends of LED UV becoming more power efficient, more compact, and flexible have really been apparent over the last few years of development, right? So where do you think LED UV technology will be in 5 to 10 years, even as we move out into the future? And what surprising products or applications do you think will be available?
Well, I mean, there's a lot of dreaming involved. The first thing that's important to note is everyone involved daily in the LED world wants to see UVC become more effective immediately. Now, UVC, if you're not familiar with it, is what's kills all of your biologicals, right? So your viruses and things, sort of an important deal going on right now with that. So if we had that available right now, that would be fantastic. But what's commercially available generally isn't strong enough for us to go ahead and use to knock out COVID-19, right? So that's too bad, but that is on its way. So the ability to get into that disinfection stage is a really, really big deal for all LEDs. I mean, just imagine what's available. You could, have a handle cover, right? So for your door handle, and it just zaps it every time somebody uses it, and you move on. That's the kind of thing that's coming from that. But those wavelengths, those lower wavelengths in the low B category and the C category, are on their way. They will get there. And we probably get 100 phone calls a month or so asking if we have it. We don't yet, but we will. Believe me, you'll read about it when we do. And that's in the short term, right? We believe that there's huge money funneled into that development of UVC, and that'll come hopefully shortly. The rest of the world is basically about re-imaging or reimagining everybody's chemistry so that they can get away from these kind of full spectrum use chemistries and move into something that's much more specific in the spectrum. So if you have the opportunity, for example, to cure exactly at 375, and that's the single best absorption rate for your product, you'll be able to use that with LED, where in the past, you're only grabbing part of that with traditional UV. So we actually see regular UV, because it's a great product, but it's got a lot of nightmares associated with it, both from a usability standpoint and from an environmental standpoint. But we see that disappearing probably over the next 5 to 10 years.
Yeah, I think, basically the conventional UV still has a lot of good uses for those UVB and UVC ranges that Hans mentioned. When you see things in the news about, disinfecting and using UV light, I mean, that's that UVC band usually coming from conventional UV right now. So, and there's also industrial processes that need those lower wavelengths that, there's LED dyes that can produce it, but they're still at a small fraction, 1% or less of where kind of the standard UVA, the 385, 395, 405 nanometer dyes are. And, that's just not really a viable thing to make a, LED product that'll only last, 100 hours and has a fraction of the output. So until that LED catches up in those wavelengths, conventional UV will still be very much used and a great technology for curing those areas.
Exactly. The other aspect too is as LED technology gets better, gets stronger, and more cost effective, and the chemistries associated with it become more efficient as well. We'll have the opportunity to say goodbye to tremendous amounts of industrial VOC usage. So a good example might be something like powder coating or someplace where they're putting VOCs into the atmosphere on a regular basis. Those can go away because VOCs are not a required part of the curing process for any of these industrial applications. And that'll be good for the environment and especially for the health of all the workers around it.
That's a great point on cost too. I mean, I think that's been a huge driver of LEDs getting pushed further and further into industrial processes. Is when we started off, they were incredibly expensive, especially like what Hans mentioned, some of the things we were doing just to make a powerful lamp. But I'm seeing now when I'm quoting customers and working with them and on their requirements and re-quoting systems or quoting similar systems that I quoted just 2 years ago, and we're seeing just massive reductions in the cost of these systems just due to the LED dye technology kind of catching up, and some of these lower wavelengths like 365 especially really starting to become more cost effective. Nowadays you can almost purchase LED for the same price or less than conventional UV systems, which is really going to keep pushing that technology forward into the market.
Right.
Well, it's been fantastic having you guys on the podcast, Hans Ulland and Michael Derrick. Guys, thank you so much for joining me here today and sharing what's exciting and what's going on right now in this particular world and giving us some insights there.
Thanks a lot, Tyler. It's great talking to you.
Yeah, you're welcome. We had a great time. Thanks.
Before we wrap up, guys, is there a website? Where should people go to find more information or to get in touch with you if they have questions, if they would like to ask or get more info from you on these products and the innovations that you're creating?
So yeah, if you want more information about all these great industrial applications, please go to leduv.com. You can go ahead and reach us there. And please remember that we know that all of your different applications are your own, and we're there to help you kind of discover those and what's going to be required from a LED standpoint. So don't hesitate to ask questions on the website either. Thanks.
Perfect. Michael and Hans, once again, everyone, thank you again to those guys for joining us here on the podcast. And everyone, thank you for joining us here on Baldwin's Unlocking Potential podcast series. We appreciate you joining us very much. Of course, for more from Baldwin Technology, make sure to go visit their website as well. And everyone, stay tuned for more episodes of the podcast. Of course, if you're joining us for this episode, we have previous episodes of the podcast you can check out. You can find those on Apple Podcasts or Spotify. And make sure you subscribe while you're there to stay up to date with the latest in thought leadership from Baldwin Technology. And of course, we'll be back soon with new episodes of the show, so stay tuned for that. But until then, I've been your host today, Tyler Kern. Thanks so much for listening.